What's up, geometry students? This is lesson 51. Our objective is what are and how do you use properties of isosceles triangles? So there are several different properties, and there's 6 of them really. They're all right here on this page. Let's see if we can go through them, make sense of them, and then use them on the next couple pages. The first one says, if a triangle is isosceles, then its base angles are congruent. So that means if I know this one is the same as that one, then I know that this angle would be the same as that angle. Okay, now I'm going to jump over here. It says theorem, this one, the converse of the isosceles triangle theorem. So notice this is isosceles triangle theorem. This is the converse of it. This one says if two angles are congruent, then the sides opposite those are also congruent. So it's going the other way. It's saying if these two are the same, then those lengths will be the same. Alright, now let's come here to this one. It says if a triangle is equilateral, meaning all 3 sides are the same, then it is equiangular. So what that means is that if I have a triangle with all 3 sides are the same, that means that I also have a triangle with all 3 angles that are the same. And then if you come over here to this corollary, it says if a triangle is equiangular, then it is equilateral. So it's going from here, going this way. So it's both directions. So if I have all 3 angles are the same, it means all 3 sides are the same. If I have all 3 sides are the same, it means all 3 angles are the same. That's those two. Okay? My last one here says, or last two says, if a line bisects the vertex angle of an isosceles triangle, the vertex angle is the one up here, between the 2 sides that are congruent. If it bisects the vertex angle of an isosceles triangle, then it is the perpendicular bisector of the base. So I'm going to come up here and draw that. So if it bisects this, meaning that this angle is the same as this angle, that means it's a perpendicular bisector of this base. That means this length and that length are the same. And then kind of the opposite of that says if a line is the perpendicular bisector of the base of an isosceles triangle, so if this line cuts that in two and is perpendicular, then it bisects the angle, means those two are the same. So these two are kind of opposites of each other. These two are opposites of each other. These two are opposites of each other. Alright, it says in triangle PQR, PR is congruent to QR, and the measure of angle R is equal to 118 degrees. Now before I go any further, I need to make sense of that. PR is the same thing as QR, and R is 118. So I'm just going to draw angle R to be 118 degrees. I did not measure that, I approximated that. It's an obtuse angle. Okay, so this is 118 degrees. And then it says that, so this is the angle R. Down here is going to be the angle P. This is going to be the angle, or the point Q. So it says PR, this length is the same as QR, that length. And that one up there is 118 degrees. So I got a triangle here. Identify the vertex angle. That would be angle R, because that's the one that is between the 2 congruent sides. It says determine the measure of angle P. Well, I don't know the measure of angle P yet anyways, but I know that P would be the same as Q. So I'll just call that measure X. Whatever it is X degrees. X degrees. So I know, since all 3 angles add up to 180, that X plus 118 degrees is equal to 180. This means 2x plus 118 is equal to 180. Subtracting 118 from both sides, you get 2x is equal to 62. Dividing by 2 to get what x is equal to 31. So the measure of angle P is equal to 31 degrees. Alright, here's another one. It says find the value of x. Find the value of x. Well, I'm noticing here that this angle is the same as this angle. That means that this is an isosceles and that this side length is the same as that side length, which means that 6 minus x is going to equal to 2/3 x. Now I don't particularly like working with fractions too much. I multiply this side by 3 and that side by 3. And I will end up with 18 minus 3x, because I'm distributing that in, is equal to 2x. So I'm going to add 3x to both sides. 18 is equal to 5x. Dividing by 5, I'll end up with x is equal to 3.6. Alright, let's try another one of these. The perimeter of triangle ABC is 21.4 inches. The measure of angle A is equal to the measure of angle B. If AB is equal to 5.2 inches, determine AC and BC. Not to be confused with AC, DC. Alright, so let's draw this triangle ABC, and notice that angle A and B are the same. So I have no idea what this really looks like. But this angle and this angle are the same. A, B, C. Okay. I know the perimeter of this whole thing is equal to 21.4. And I know AB down here is equal to 5.2 inches. I'm looking for this length over here, AC, this length over here, BC. Well, I know because this angle and that angle are the same, that this side length and that side length will be the same. So I'm going to do something similar to what I did earlier. I will call this side length x and that side length x, so the same. And I know that the perimeter is going to equal to x plus 5.2. Well, I know the perimeter, right? So I'm going to say 21.4 is equal to 2x, because x plus x is 2x, plus 5.2. If I subtract 5.2 from both sides, on the right hand side I end up with 2x, on the left hand side I end up with 0.2, 26.2, dividing by 2, I end up with x is equal to half of 26 is going to be 13.1. So I'm going to say AC is equal to BC, which is equal to 13.1 inches. Alright, your homework is on page 339, and all you have to do is a lesson practice. And honestly, I don't think it's going to be too hard. There's not even any proofs in that. So good luck. I'm sure you're going to do great.